Okay, let's start by writing down the limit definition of the derivative, which is f prime of x equals lim h goes to 0 of f of x plus h minus f of x all divided by h. So here's my f here. So f of x plus h, what I do to find this is just take this x here, this guy, that little guy, and replace it with x plus h. And a common mistake is to write f of x plus h is this, which is no good. Okay, next. F of x is easy, it's just this thing. And all this is divided by h. Okay, I got a fraction or some fractions inside a larger fraction. So what I often do is I multiply top and bottom by the same thing. Multiply top and bottom by the same thing. And that thing is chosen so that my denominators will go away upstairs. So what I'm going to do is I'm going to multiply by root x times root x plus h, because that will kill this denominator and also this denominator. And I multiply top and bottom by that. And we'll get a nice simplification. What do we get? Lim. Now you imagine this guy sitting on top there. And the cancellation is this cancels with this, leaving just root x. Similarly, over here, we're going to get minus root x plus h, all divided by this product here. H root x plus h. Okay, now we'll do a rationalization of the numerator. So again, multiply top and bottom by the same thing, which is the conjugate of the numerator. And this will make us happy permanently. Oh, maybe not permanently. So we get x minus x plus h. Oh, I think I did something wrong. I did something wrong. Do you see what I did wrong? I'll come back to it in a second. I did something wrong. I made a mistake. Do you know what my mistake is? Okay, rationalize the numerator. On top, I have a problem. My problem is I need brackets here. If you don't have brackets there, if you don't have the brackets, then you're subtracting the x, but actually adding the h, when really what you want to do is subtract x plus h. That's what I want to do. Okay, so those red brackets are necessary. So very common mistake. Please watch out for it in the future. So my limit is negative h on top, and this big mess on the bottom. Okay, and again, h is going to 0. Oh, I can't quite do that yet. I have to do my cancellation. The whole point of all this fancy footwork was to obtain that cancellation there. So don't forget that, Jordan. Let's get -1 over root x plus h bracket root x plus. That's a funny looking plus sign. Oh, that's even funny. I'm just gonna quit while I'm ahead there. Okay, now what? Now we can recall that h is going to 0 and see that our problem does not exist anymore. Okay, our problem was we had a limit, up there we had 0 over 0, but that is no longer happening here. Okay, so we can plug in our h equals 0. Okay, we have no problem here, so just plug it in. -1 over, what do we get? Root x plus root x, which is -1 over, that's just root x times root x is just x. And then we have 2 root x. And if you want to make this a bit prettier, we go 2x root x for our final answer.